And it's my honor to represent my department with 57 regular faculty members and 1,000 students. Traditionally, Department of Mechanical Engineering in KAIST has been the everlasting friend of Kim in 5 minutes distance. So this will continue again forever. And today, actually, my talk in the title of Vision of Energy Sustainability, which was very instantaneous making of the title when Professor Dr. Im called me for some kind of meaningful talk. It seems to be too big, but I would like to overview some scenario of energy technologies, which is based on International Energy Agency Energy Technology Perspective 2050, and then I will give you some examples of the efforts to achieve this energy technology perspective in KAIST. I don't know what's going on there. Okay. Let me first overview the energy technology perspectives so that we could understand what kind of scenario we have from the governmental point of view and from the industrial point of view. So I will start from the ETP 2050, which was initiated by International Energy Agency. Do you know? Should I push the button up? Okay, sorry. From 2006, International Energy Agency set up the ETP 2050 as a representative of Korea in combustion implementing agreement. This was initiated in 2006, and this was revised every 2 years until 2010, when we have too much ideal scenario. Just after that, we had the hazard in Fukushima in 2011. So after that, IEA made a new name from the original scenario. The original scenario was baseline, ACMAP, and BLUMAP scenarios. Baseline scenario is basically following the natural trend of energy technology development. So IEA made the plan that CO2 emission in 2050 will be doubled compared to 2005. That was the baseline scenario of IEA, which was set up in 2006. At that time, the ideal scenario was BLUMAP. The target of BLUMAP was to keep the CO2 level the same at 2050 compared to 2005. This one was renamed and revised to these new scenarios: 6-degree scenario, 4-degree scenario, and 2-degree scenario. Every government set up the energy technology policies following the BLUMAP scenario mostly. Korean government set up the green growth policy following the BLUMAP in 2008 or so. And now this is following the 2-degree scenario. This naming itself is very appalling for us. Since we are now experiencing record high temperature and humid weather, if you consider the 6-degree increase in 2050 compared to 2013, that's the baseline of this scenario, which was the most recent one, 2016, you cannot imagine what will happen if the temperature will increase by 6 degrees. Of course, there are some argument that it may not happen even with this baseline or 6-degree scenario trend. Still, United States, Japanese, and Korean governments are keeping the energy policy following the blue map or the 2-degree scenario of IEA. And this is enforced by the recent agreement by COP 21st last year. I remember that was around October or so. And it was the time when the fuel price, especially the petroleum price, was becoming very low because of the advent of shale gas. That was a big change in the fuel market, but that gives some advantages and disadvantages in energy technology development. This is the detail of 6-degree scenario and 4-degree scenario and 2-degree scenario compared to baseline scenario here. In 2050 compared to 2013, you will have this amount of increase of fossil fuel and renewable natural resources, while in 2-degree scenario, you may reduce the consumption or supply of these fossil fuel energy resource, while you will have a lot of increase of renewable energies. Renewable energy includes the biomass and waste, hydro-driven energy, and other renewables like solar, wind, geothermal, and so on. While this natural gas, oil, and coal will be dominating still, even in 2-degree scenario. Comparing 6-degree scenario to 2-degree scenario or 4-degree scenario, you must achieve the reduction of CO2 this amount, some tens of gigatons, by the contribution of this kind of technologies. Among these optional technologies, the manifest significant technologies are mostly renewable energy and end-use efficiency. Actually, this is the main message I would like to deliver today. When we say the sustainable energy technology, we always think about the renewables. But the renewable energy cannot solve everything, and renewable energy cannot be acquired at cheap price and easy technology development. So you must have the balance with the end-use efficiency improvement. So you must tackle this parallel technological development, one, the innovative renewable energy development, and the other one, the efficiency improvement based on the traditional energy technology. This is another separation of the 2DS in 2-degree scenario compared to 6-degree scenario in different sectors. As you could see, power generation is the biggest sector, which is consuming the energy and which must contribute for the CO2 reductions with the 2-degree scenario technical development. Industry, transport, buildings, and the transformation in the fuel supply or the natural resources supply. And in each sector, you could see the contribution of different technology items. And this is the energy flow from different energy resources such as renewable energy, fossil fuel, and nuclear energy to different sectors. Still, even for 2-degree scenario, you could see that fossil fuel is still 40% of all. It means that you need the efficiency improvement with the traditional energy facility. I tried to itemize all the possible issues which we must tackle sector by sector. In the power generation, the coal and natural gas will be still the major energy resources for the power generation. When we are still using the coal and natural gas, we need to implement the CCS, carbon capture and storage. Solar thing is trendy but expensive. We are tackling the solar photovoltaic and solar thermal energies, wind, hydro, geothermal, and ocean energy, biomass, nuclear. And even in electricity systems, we need to improve the storage and the transmissions. The next sector is the industry. These industries like iron and steel, cement, chemicals and petrochemical, pulp and paper, aluminum, these industries are in trouble in making CO2. So we must solve the CO2 problem with this sort of techniques. Let me skip the details of that. And transport, you may think of mostly the light-duty vehicles, the passenger cars. In the passenger cars, you can think of the innovative technologies like plug-in hybrid, battery electrical vehicle, fuel cell electrical vehicle, while you must improve the efficiency of the traditional gasoline diesel engines, and the application of alternative fuel is an important item. And in the commercial transport systems, you could think of intelligent transport and electrified infrastructures for a certain niche market and application of alternative fuel. And modal shift is very important. You need to shift the transportation mode. And shipping needs the operational improvement. In the aviation, you have some limitations, but still you could utilize some alternative fuel while you improve the efficiencies. Last sector is the building. For the buildings, you need to set up the new technologies for the envelope or the improve the efficiencies and the insulation and the efficiencies of heating, cooling, and water heating. The lighting is an important. Lighting is also an important part to improve the energy efficiency, appliances, ventilation. When we talk about this 2-degree scenario, the biggest problem is the economic burden. The baseline scenario or the 6-degree scenario still need this amazing amount of money to invest. That's the routine investment. $434 trillion for the 34 years. That's the basic. And to achieve this 2-degree scenario, we need additional $12.6 trillion. Compared to original spending, $407, it seems to be small, but that's $400 billion every year additional investment at this economic situation. It looks almost impossible. So there is a big investment issue, and another thing is that for this investment, transport takes around 80% of all. Even though transport is emitting only 18% of CO2, all the regulations and the investment requirement is given to transport. As a researcher in the car technologies, especially power plant technologies, I always feel that it is really unfair that all the regulation and the push and the financial burden is given only to transport. For example, everybody is attacking the diesel engine. Diesel engine is producing only single digit of dust or the particles, but everybody is trying to kill diesel. The only reason for this is that all the other sectors like industry, buildings and power, it's not easy to touch. But transport is completely commercialized, so you can push these industries. It's unfair, but that's the reality. Even though we are talking about the renewable energy and the sustainability and so on, but still we still have lots of fossil fuel. So So until 2040, it is expected to have a quite stable supply of petroleum, coal, nuclear, and especially natural gas. Actually, this was given last year, but still they think of changing this value drastically because now the shale gas supply is now demolishing the traditional energy resource model. This is actually the major part I would like to say. When you consider the option of energy technologies or the sustainable energy system, we must think of these four factors, such as energy security, economic viability, environment, and technical feasibility. Nothing is more important than the others. Sometimes you could give some priority to some options. For example, in Brazil, most cars are run by alcohol because you have lots of sugar. In Korea, all the taxis are run by LPG because Korea is very keen at the energy security. So we need to diversify the energy supply. So taxis are run by LPG, buses are run by natural gas, the cookings are given by the natural gas, and electricity is mostly given by the coal. Of course, we have 20% of gas and nuclear, 30%. So we need the balance between the different energy technologies. So vision by vision, time by time, you have different strategy, but you must think of the balance between these four considerations. That's what determines the local sustainable energy system policy. I feel obliged to talk because I found that the program says I have only 20 minutes, followed by coffee time. I will fly over some remaining pages. Let me give some example. The first one is transportation, because in this scenario, transportation is the biggest part you need to invest, and you need to develop the innovative technologies. Among lots of options in the propulsion system for the car, the conventional internal combustion engine, gasoline and diesel have been dominating the market by more than 95%. But all the people are talking about the battery electrical vehicle or fuel cell or the hybrid electrical vehicles, and it seems to be shifting the technology from here to there tomorrow. But practically, it is not like that. This is the collection of the prediction of this car market. This is IEA baseline or 60S scenario, 4DS. And improve means 4DS, improve with the modal shifting and avoid strategy included. So that's the most innovative and drastic change in 2050. Still you have gasoline vehicles, diesel vehicles, and you have lots of hybrid electrical vehicles, but still that's run by gasoline or diesel. And you have this amount of electrical vehicle and fuel cell electrical vehicle. As long as you solve the problem of economic viability of batteries and the hydrogen production, that's the basic assumption. And these are predictions from ExxonMobil and European project and IHS in States. Here you could see that these yellow boxes are based on the conventional gasoline engine and diesel. So even in 2050, the cars are still run by gasoline and diesel. Don't expect that all the cars will be shifted to battery electrical vehicle or fuel cell vehicle. It is impossible. It is impossible because of technical maturity, economic viability, energy security, and even environmental issues. The people think that this electrical vehicle is very clean. No, because in Korea the electricity is made from 65% of fossil fuels, and the energy efficiency to transform from there to the battery is very low. It is worse in Germany, it is worse in east part of states, so we need to make the balance between the options of energy supply. Let me give you some examples in my department, what kinds of things we are working on for new energy technologies. This is my work. When we apply this biodiesel, the combustion is better in that it reduces the biggest trouble, particulate matter, carbon monoxide and hydrocarbon, while you may increase some nitrogen oxide, which could be dealt by the EGL application or SCR. And we have tried to utilize the DME, the demethyl ester, having the oxygen in the fuel. You could see the difference in the combustion phenomena in that it is producing lots of carbon radiation, while it is well mixed with a less amount of soot production. One of my colleagues is working on fuel cell, not one of. Some tens of people are working on fuel cell in mechanical engineering, chemical engineering, and materials, and electronical and electrical engineering. One of my colleagues in mechanical engineering is working on solid oxide fuel cell for the auxiliary power unit. This is reforming even diesel. And another example is the all-polymer solar cell development. This is making quite good strength and ductility and flexibility with less cracks. I'm sorry, I don't know the details of this. And this has a very good conductance and very flexible, so you could use this kind of thing at the wearable devices. And another staff is working on the energy harvesting. This is an example. He's working on you could see the membrane and this platter. There, if you put the piezoelectric patch, which can generate electricity, this is refined energy harvesting. But still, it's very expensive, and technical maturity is a way to go for long term. And this is an example of graphene-assisted near-field thermal photovoltaic system, which is regenerating the wasted heat in the energy systems. And one senior staff is working on the insulation. He developed a very good vacuum insulation system which can reduce the energy loss. So he showed a vision of the 70% of energy saving with less than 10% of sickness in buildings. This is applied to refrigerators and LNG tanker and the parts of automobile system and all the other small systems as well. He achieved this much of heat transfer coefficient, almost nothing. And his graduates are making the companies to sell this insulation material and its systems. Let me summarize my talk, even though my message is very simple. Looking at the three scenarios from International Energy Agency for 2050, we could see that 6-degree scenario is realistic, though it has this appalling number 6 for 2050. This ambitious 2-degree scenario is still very idealistic and it needs a lot of investment. Whenever we think about the energy systems, we must make the balance between these four considerations: environment, energy security, technical feasibility, and economic viability. And for us, for the scientists, we need still a mix of conventional and economically viable energy system and innovative renewable energy systems. And we need the R&D to break this bottleneck of the really sustainable energy system in the long term. That's it for me.